Hey, this is Math 7, Unit 5, Lesson 16, representing context with the equations here. So the first part is don't solve it. Is the solution positive or negative? Just taking a look at the situation and deciding, would I get a positive or a negative solution here? So looking at this variable here, kind of looking at, I have a negative number times a positive number, and whenever I have a negative times a positive, I end up with a negative type of solution here. Here I look and say I'm going to divide by or multiply by b, and whatever b is going to be, I have a negative number here times something else, and I want to end up with a positive solution. So in order for that to take place, what kind of number do I need to have? I'm going to need to have a negative number, so b needs to be a negative value there. When I look at this guy here, I'm going to have the c left by itself, so it means I'm going to move this guy over there. When I move that over there, I'm adding the opposite, right? So at plus 8.7. So I'd be left with a negative 1 and a positive 8, so I should end up with a positive solution here. In this situation here, a little bit differently, I can think of it a couple ways. I can move the d over to here, right? By doing a plus d. I can put the d on this side. And if I put the d on this side, it makes the d positive. Then I don't have to worry about it being a negative d value. And then what I can do is I could then move this one over to there by the opposite. So now I have a positive 1.4, right? So looking at the d here and here, now I have a plus 1 and a negative 8, which means I'm going to have a larger negative value. So the solution to that one would be negative in that case there. In 6.2, it's called warmer or colder than before. It says find two equations that could represent the situation from the bank of equations. Some will not be used. And explain the variable v, what it represents, and then determine the value of the variable that makes the equation true, and explain your reasoning. Okay, so we have a variety of equations right here, and we're going to go through some questions down below and see which ones go with it. All right, so if you want to, you could think about, well, these are going to be your possible choices, but it might be good just to read the statement here and write up your own equation to see what would you come up with, because that's what ultimately you're going to have to do at some point, right? So between 6 a.m. and noon, the temperature rose 12 degrees. So it's going to go up 12 degrees Fahrenheit, and it landed at 4 degrees Fahrenheit. So the temperature between 6 and noon, it went up 12 degrees, and it went all the way up to 4 degrees Fahrenheit. So I'm not solving anything here. I'm just looking at what it could be. Now I'm going to erase the t real quick because I noticed that all of my choices up here are v for a variable, right? So there's some variable v. Okay. So my variable v is going to represent my starting temperature, is what my v is going to stand for. So whatever that is, starting temperature plus 12, is going to get you up to 4. Okay, so do I have an equation up here that looks like that? Well, I have v plus 12 equals 4, so this one right here would certainly work for that situation. That would work just fine, right? If I was to rewrite this one, I could rewrite this also as v equals 4, and then adding a negative 12, right? That would work as well, which isn't one of the choices here, but that could work. Actually, it's right here. There's a choice there for you, so it could work. So that's the idea. Read the question, write an equation that would work for that, and what does the v represent? At midnight, the temperature was negative 6 degrees. Okay, so the information there, we know negative 6. By 4 a.m., the temperature had fallen, going down to negative 16 degrees. So we know that at midnight, we're at negative 6. And then we're going to drop some more, and we'll end up at negative 16. Okay, so the variable in this case is going to be how much of the temperature has fallen, in that case, to go from negative 6 to there. I could write this as negative 6 plus v. It really doesn't matter. That's just we're adding to the change. If it's a negative v value, then it works out the same. So that might be a better way to write that out. Okay, and so in terms of my situations that I have to work with here, I can see I have one up here, negative 6 plus v equals negative 16. That works out just fine. If I was to move things around, I'd say that v equals negative 16 plus a 6 by moving that over there. And that's another choice. Number 3, it says the temperature is 0 degrees at midnight and dropping 3 degrees per hour. Okay, so it's going to drop 3 degrees every hour. We can call the hour the number of hours we're doing. Okay, the temperature is -6 degrees at a certain time. So it's dropping 3 degrees every hour, and eventually it gets to a point where it's -6 degrees. So if 0 is midnight, all right, here's my number line, if 0 is midnight, and we're going to be dropping 3 degrees every hour, every time it hits another hour, we go down 3 more. So my variable here happens to be the number of hours this is taking place, right? So we would say -3, oops, sorry, I should say -3 since we're dropping, sorry about that, dropping, -3, that's my rate every hour, and I want to find out when I get to be at -6, right? So if I was to solve that, I would multiply by the reciprocal times the -1/3, and my variable here for my hours would actually equal 2, right? You get -6 over -3, which equals a +2, right? And that's the idea there. All right. Down below, the temperature is 0 degrees at midnight and dropping 3 degrees per hour. So that's our rate again, dropping 3 degrees every hour. The temperature is 9 degrees at a certain time. So we have something that looks a little bit like that. Okay, and so that's what we have. Okay, so for this one here, we would divide by a -3 or multiply by the reciprocal. So that V would equal 9 times -1/3. So both of these are good equations that you could use. And here it is, temperature 9 o'clock is 1/3. So temperature at 9 o'clock is 1/3 the temperature at midnight. Okay, so if we took the temperature at midnight and called that our variable and multiply that by 1/3, that's going to give you the temperature at 9 o'clock. Okay? So the temperature at 9 p.m. is 1/3 the temperature at midnight. All right, so 1/3 temperature at midnight. Now what I don't know is the temperature at midnight. Oh, that's the V. And this is the temperature at 9 o'clock. So the 9 p.m. temperature. It's going to be equal to that. So I look back up at my equations of what I had to choose from there. The only one that would work is I do have a V times 1/3 equals -4, so we're going to go with -4 right there. All right, and that's the idea. That's all I got there. So we're going to leave it like that and move on to the next one. So the next situation, we're changing altitudes, and so you have to match each situation with a diagram. And so you have a penguin standing 3 feet above sea level and then dives down 10 feet. What is its depth? So we're starting at a +3 and we're going to dive down 10 feet. Okay, so looking at what we have, for example, this penguin one's going to go with A right there with number 1. Why? Because the penguin is starting, we go 0 and it's starting at 3 feet, and then we're going to dive down 10. And so we go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this equation here represents, in our case here, 3 minus 10 equals A. Okay? And so what will A equal? A is going to equal -7. So that's the point at which he's actually going to be at that point there. This equation is what you have to do on the next page. It does ask you in number 2 to write an equation for each of these here. I'm just doing it as we go along. Okay? So for number 2, we can see that something is going to be going 10, and then it's going to end up over here at 3. Okay? Ends up at 3. What's that going to be? Not sure. Here we're going to be looking at number 3. We're going down -10, and we end up at -3. So we have a variety of situations here to look at. This one we're going down 3 and then going up, looks like 10 more. Here we're going down 3 and then down 10 more again. And here we have a point and we're going up to 10 and ending up over here. So let's look at our stories. So the dolphin is swimming 3 feet below sea level and then jumps up there. So we're starting at a -3 and then we're going to go up 10 feet. And we're going to find the height at the top of its jump. Okay? So when I look over here, this guy here goes down 3 feet and jumps up 10. So that one's going to work for our dolphin. This is B. This is our dolphin right there. And the reason that works is because you're starting at -3. We're jumping 10 feet in the air to get to where we need to be for the dolphin. So what's our B value going to be? B is going to equal 7, which is where the dolphin ends up at. A sea turtle is swimming 3 feet below sea level, so minus 3, and then dives down 10 feet. We're going to go down 10 more. What is its depth? So we need to find one that goes down 3 and then goes down 10 more. When I look over here at number 5, we can see we go down 3 and we go down 10 more. So this is going to be the sea turtle here, which we're going down 3 and minus 10 more is going to equal C. And so our value of C is going to equal negative 13, which is where you're located on that spot there. D says an eagle is flying 10 feet above sea level, right, plus 10, and then dives down 3 feet. That's where it ends up at, right? So it goes down something and ends up at 3 feet above sea level. What is the change in altitude? So we're at 10 and we're going to go, we're at 10 and we go down something and we end up at 3. So where do I go 10? Looking right here, number 2, I'm going up to 10 and we're going to go down and end up being here. So the question is, how do you get from there to there? So this is a 10 minus something, and we can call this is our eagle. This is our eagle one, which is D. So 10 minus D equals 3. So in our case, to solve for this one here, 10 minus what number gets you to 3? Well, that's going to be 7. And we can look and see that it's 1, 2, 3, 4, 5, 6, 7 there as well. A pelican is flying 10 feet above sea level and then dives down, reaching 3 feet below sea level. So it's going to go down, all right? So we're going to go down some, dropping down, and we're going to be then going to 3 feet below sea level. All right? So we're at 10 feet above. We need to start 10 feet above, which that one's not starting 10 feet above, so that's not going to work there. Here, we start, number 6, we start 10 feet above, and we're going all the way down to this point there. So number 6 is going to be our pelican for E. And we could say that this is 10 minus E equals negative 3. So 10 minus what number gets you to minus 3? In this case, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So E is going to equal 13. 10 minus 13 is going to get you to a minus 3. Okay? If I did it as an addition statement, I could say it's 10 plus a negative 13, right? That would make more sense because it's diving down. So that would make sense there in that regard. Depends on how you want to set that up there. So E is going to be equal to 13, but if you set an equation of like this, then you'd say you're adding a negative, right, to equal negative 3. So you have to decide how you want to write that there. If I solved it for E, I'd end up with E equals 13. And then finally, our shark is swimming 10 feet below sea level, right? It's at minus 10, and then swims up, reaching 3 feet. So we're going to go up and then get up to 3. All right, so this shark is down here, we can see, is 10 feet below. It goes up something and ends up at 3 feet below there. So our shark is going to be at negative 10 plus some value of F gets into negative 3. In our case here, our shark is going to be F is equal to 7. So this is an F, this is our shark, and there we go. And that's the idea there. I had to skip around quite a bit. It's hard to do with the paper moving all over the place, but that's just kind of the way that works there. Let's take a look at the next section before my bell rings here. Okay, in this situation here, you are going to be assigned by your teacher one of the situations, and you're going to create a visual display about your situation and write an equation for that. So write an equation, figure out the variable, how do you represent in the story, positive, negative, and how do you solve for that there. So let's take, for example, a couple of these. I'm going to do a couple, and then I'm going to not do them all because you're doing them in the class. So as a 7 1/4 inch candle burns down, its height decreases 3/4 of an inch an hour. How many hours does it take for the candle to burn completely? For something to burn out completely, that means that the candle height is going to be 0. It's going to be gone, right? So we know that it starts at 7 1/4 of an inch is where it's at. Now we're going to take away from that 3/4 of an inch every hour until it gets down to nothing, right? So I do the start of the candle height, 7 1/4, and I'm going to take away 3/4 of an inch every hour until I get down to nothing. So if I was to solve that, I would say that negative 3/4 h equals negative 7 over 4. I can write it that way there, and I can go through the process to solve that. Okay, so that's kind of set up for what you would do. You can figure out that solution on your own if you like. Again, well, I'll do it real quick. You have 28, 29. This is negative 29 over 4 on this side. Here we're going to multiply by the reciprocal, so negative 4/3, so negative 4/3. That's going to cancel out, and you're left with negative 29 over 3. That's what that one is going to be. Oh, no, positive, because we're divided by negative, so positive. So 3 goes into there 9 times with 2 left over. So we would say that it's going to take about 9 2/3 of an hour for the candle to be completely out there. Okay, and that's the idea there. Another one real quick. On Monday, 1/9 of the enrolled students in school were absent. There were 4,512 students present. How many are there? So this is saying that 1/9 of all the students were not there. So if we take our student population and we take away from it 1/9 of them, because those are the absent kids, we're left with the attendance that day, 4,512. So our students minus 1/9 that are absent, that's our absent number, 1/9, is going to be left with how many were there that day. So that's your setup, so you can solve that and figure that out there. So that's your assignment there. You can do that as a class and work through those together and then just see how you do. We'll pause there and you can work on your homework, and then we'll get you some solutions here for your homework for the day. All right. Alright, so here's the homework. We have to match each situation to one of the equations. We have a whale diving at a rate of 2 meters per second. Now notice that it's diving, which means it's going to be probably going down. So this is probably looking for a rate of -2 somewhere over here. Now I have a -12, I have a -12, I have a -2 here, and -12. So far I'm probably going to go with 3. Let's see what else we have. So how long will it take for the whale to get from the surface of the ocean to an elevation of -12 meters at that rate? So we're saying it's going at -12, and it's going to do that for X amount of time, and it's eventually want to know how much time will it take going down 2 meters per second to get to -12. That's the equation we're looking for there, which matches this one right here. So A. So A is going to go with number 3. Okay. It says the swimmer dove below the surface of the ocean. After 2 minutes, she was 12 meters below the surface. At what rate was she diving? Okay, so the swimmer's going down here. Okay, we don't know the rate at which she's going. Okay, what we know is that she's going at some rate after 2 minutes. So in this case, our rate is what we don't know, right? There's some rate that we don't know about. So that's our unknown rate for 2 minutes gets her to 12. Okay, the other way of writing this would be 2x equals 12. I just put the x on this side to start with, so some rate times 12, because over here it was our rate was -2 for a certain amount of time to -12. Here we don't know the rate, we just know it's for 2 minutes to get to 12. So this one, and sorry, below the surface is -12, my mistake, sorry, -12. So that's going to match over here with B, number 4. So the rate of 2 for some amount of minutes to get to -12. The temperature was -12 degrees Celsius, -12 degrees Celsius, and it rose, so it goes up to 2 degrees Celsius. So it's going to go up some amount and get up to 2 degrees Celsius. And that's going to match, if we look over here, with number 1, so this is C. And then finally, the temperature was 2 degrees Celsius and fell, so it's going to go down something. Right, that can be getting down, or it can be adding something, a negative amount possibly, and it fell to -12 degrees. So it started at 2, goes down some amount, and it gets to -12 degrees. So that's going to be D right there. All right, number 2. Starting at noon, the temperature drops steadily at a rate of 0.8 degrees every hour. That's our rate, 0.8 degrees. For these situations, write and solve an equation to describe what your variable represents. How many hours did it take for the temperature to decrease by 4.4 degrees Celsius? So we know that our rate it's dropping, is at -0.8 degrees for every hour, and we want to know how many hours would it take in order to get to 4.4 degrees Celsius. So that's our idea. And we're going to decrease by, how many hours does it take to decrease by 4.4 degrees? So we're going to want to get a negative answer here because we're decreasing it to negative 4.4. So we want to know how long does it take to drop down to there. Okay? And that's the idea there. Okay. If the temperature after the 4.4 degree drop was negative 2.5, what was the temperature at noon? Okay. So now we're going to say our temperature minus 4.4, right? That's our drop there. Whatever the temperature was, it dropped that much. It was going to be equal to negative 2.5. Okay. So the temperature at noon minus 4.4 is negative 2.5. Okay, and that's the idea there. That's how we would solve for the temperature there. And so you work that out and get a solution there. Okay, the next one. This was another one of those crazy ones here. Kieran mixes 3/4 cups of raisins, 1 cup of peanuts, half a cup of chocolate chips to make trail mix. How much of each ingredient to make 10 cups of trail mix? All right, so a little bit complicated here. Let's first of all see what we're making. We have a 3/4 cup of raisin, and we're adding a 1 cup of peanuts, and we have a half a cup of chocolate, which is also 2/4. So I'm converting each of these to 4/4 to say that I'm having a total of 9/4, which is the same as 2 1/4, or 2.25 cups is what I'm making already with that mixture right there. Okay, so let's take, for example, the peanuts, for example. So for the peanuts, we have, I use 1 cup of peanuts makes 2.25 cups of mix. And if I want to go for how many peanuts do I need in order to get 10 cups of trail mix, I'd set up a proportion like this, and I'd end up with 10 equals 2.25x. I'm going to divide both sides by 2.25, and we're going to find out that in our case here, 2.25x, if I did the decimals here, 10 divided by 2.25 gets me 4.4, repeating, 4.4 is about x. If you use fractions, which you could have used fractions, instead of doing 1 over 2.25, you could have used 1 over, and this becomes 9/4. 9/4 equals x over 10. If you cross multiply, then 10 equals 9/4 x, multiplied by the reciprocal, and then you end up with, so 4/9 there, you end up with 40 over 9 equals x for peanuts. Now, are those about the same? Yep, they're about the same. So that's the idea for peanuts there. Okay, we want to do the same thing for our raisins. All right, and again, you could use fractions. So for your raisin setup here, we know that raisins is 3/4 that goes into 9/4, right? 9/4, and that equals x over 10. And so really, the 10 comes up here to this part up there, so you end up with 30 over 4, right? 30 over 4 all over 9 over 4 equals x. Multiply by the reciprocal. When you do that, you end up with 30 over 4 times 4 over 9. The 4's go away, and you're left with 30 over 9 for the raisins. When it comes to the chocolate chips, same idea. We're going to go ahead and use our, we have 1/2, right, is what we have right now. 1/2 goes with our 9/4, and that's going to equal x over 10. So we put this up here, we end up with 10 over 2, which is 5. So you have 5 divided by 9/4, multiplied by the reciprocal. So 5 times 4 over 9 equals x. That's going to be 20 over 9 is how many cups of chocolate chips you would need. So a little complicated, a little bit hard to do sometimes, but just work through it, and it does work out once you set up your proportion the right way. Okay, look at the next side. Find the value of each expression. We have 12 plus a negative 10. The signs are different, so we're going to add those up, find the difference. 12 minus 10 is 2, and the bigger sign is positive, so we keep it positive. Here we add the opposite, signs are the same, so I find the sum and keep the sign the same. So 5 and 6 is 11, and we keep it negative. Here the signs are different, so I find the difference, 42 minus 17, which equals 25, and I keep the bigger sign, so we're going to say negative 25. Here, add the opposite, so just add addition. 35 plus 8 is 43. And here the signs are different, so I find the difference and keep the bigger sign. So we're going to keep it negative. Negative 4.5 minus 3 is negative 1.5 there. Number 5, the markings on the number line are evenly spaced. Label the other markings. So evenly spaced, so if this is 30, half of 30 is 15. So we're counting by 15s on every hash mark there. So we're going to write negative 45, negative 60, and negative 75 there. And our last one, Kieran drinks 6.4 ounces of milk each morning. How many days does it take him to finish a 32-ounce container? So 6.4 ounces every day to get to 32 total. So that's our equation that we would use there. And then the variable stands for the number of days it's going to take to get things done. We divide by 6.4. And we find is the number of days. It would take him 5 days to finish all of the milk. Great job, and we'll see you next time.